are we getting jobs right now as someone who's mining? Like I have a rig right here. This is mining Dynex. Are we getting jobs, or do I have to like sign up into a program to get a proof of useful work job?
No, this is actually one of the unique things that we have built here at Dynex, right?
What is going on, everybody? DJ Mines here, and today I have the pleasure of interviewing Sumi from Dynex. How's it going, brother?
Hey there, how are you? Thank you for having me.
Oh man, so it's been about 2 months since we last spoke. What would you say
Yeah,
has changed for Dynex?
well, quite a lot actually. I mean, 2 months feel like 2 years in our industry, as you know.
Yeah,
So there have been quite a number of developments. First of all these exchange listings, right? I mean, now we are listed on Maxi, on Bitmart, and LBank, and so on and so forth. So in total, we are listed on seven centralized exchanges now. So that has been a major step for us, and also
congrats.
gave a lot of credibility. Yeah, so that was one of the major parts.
So I see, according to the website, there's about 211,000 graphics cards supporting Dynex, man. That is quite an accomplishment.
Yeah, no, this is crazy. I mean, our goal for Q3 actually was to have 5% of the GPU miners utilizing their power for the Dynex platform. Now, if you look on Hive statistics, right, on Hive, uh, just now, I'm just pulling it up, we are actually number three of all GPU mined coins. So that's Casper number
Wow.
one, Ethereum Cash Dynex, and we are at 9% market share already. So that's quite cool. We're super happy about it.
Yeah, man, that's huge. And I keep seeing, Bitcoin's kind of consolidating right now, but Dynex just hit all-time high the other day, and we're like right there at the making of this video as well, man. It's quite impressive to see Dynex move.
Thank you very much. Yeah, well, the core and center part of our whole project is actually having a lot of GPU miners, right? So, and we are super thrilled because I mean our end goal by end of the year is 15% of all GPU miners, and I think that's actually doable.
Yeah, man. I love mining Dynex because it's such an efficient algorithm. And for me, my electric rate's pretty high. So it's been very good on my electric rate. I mean, it's brought down like $300 or $400 and still been pretty profitable. So I do have a question. According to the website, what is Dynex chip? I see there's 265 million chips. Can you explain that to me?
Mhm. Mhm. Well, I mean, that's also one thing that changed since we last spoke. I've been talking about the marketplace last time, that we're going to launch a marketplace going forward. But the real big enhancement, what we have been working on in the last 2 months, besides exchange listings and stuff, is basically what we call a job type machine learning, right? Because currently we have job type constraint satisfaction problems, which is quite abstract for people to understand, right? It's very niche for the average user. Machine learning is more broad, and I give you an example what that means. And give me 5 minutes just to explain you.
Take your time. This is your show.
Awesome. Yeah. So basically, I think it's without doubt that quantum computing is being the next frontier, right? I mean, quantum computing has superposition, they have entanglement, super efficient. So a lot of energy has been spent on from researchers to find new algorithms, right? How to really leverage those quantum computing paradigms, right? And the only problem is, obviously, as of now, we still have weaknesses. Quantum computers, they have still not figured out error correction quite yet. The operating temperatures, I mean, you need to operate it below, I don't know what's minus degrees. So it's not really practical to have your quantum computer at home, right?
Right.
Also have a scaling issue. I mean, the largest quantum computer we know of is operated by D-Wave, which is a fantastic company. They have around 5,000 qubits. So what does it mean? Basically, 5,000 bits you can calculate with, right? So that's very limited because if you want to run, and I'm going to get to it in a minute, a real-world problem, or you want to compute something large, you hit this 5,000 qubits limit quite fast. Now, the interesting thing is, and this is actually, we realize this more and more, and probably our Dynexians out there have not even realized it yet. Every algorithm which has, or not every, but most of the algorithms which have been designed for quantum computers can also be run on a neuromorphic computer. Yeah, that's the interesting part, right? So now, if you go to machine learning, for example, right? I mean, there's quantum support vector machines, there's quantum Boltzmann machines, there's quantum neural networks. I mean, there's tons of algorithms out there which are super efficient on quantum machines. But then again, you can only use it for smaller problems. I mean, let's just a handwriting character recognition, right? You cannot even do that on full scale pixel size because they don't have enough qubits. Now, what we did is with our job type machine learning, and this is actually which was like it was not planned, but we decided while we're doing it to do it like that. We basically made it 100% compatible to all those quantum libraries out there. So everyone who's already using quantum computers in Python, for example, right, and is formulating problems and algorithms, when he wants to use Dynex instead of, let's say, the D-Wave quantum computer, she just sends the command not to the quantum computer, but to the Dynex NUT platform. And on the Dynex platform, you don't have these limitations of qubits. Right? On the Dynex platform, and this is what I was asking before, you can run a problem with 1 million or 10 million or 20 million variables and still have this efficiency. So now we have, every week or so, we have been publishing sample codes, right? So we did breast cancer detection, for example, right? And everyone can look at it, right? It's on our GitHub, right? Dynex SDK. It's Jupyter notebook, so basically everyone can see the code, can see the results. What's the problem with breast cancer detection? They are false positives. A woman goes to the doctor, right? The computer says you have breast cancer. You imagine if 10% or 25% of the predictions are incorrect, what it means for a woman, right? And by applying quantum algorithms, you reduce this to like 1% false positives, right?
Wow, that's a big improvement, definitely.
Or we also showcased, which is extremely interesting, which is the quantum Boltzmann machine. So if you train, let's say speech recognition or whatever it is, right? Doesn't matter, character recognition, anything. So you train that, and we did an apple-to-apple comparison, right? So we took basically the public available data set, we trained it in the traditional way with traditional, machine learning models. And it takes this model around like 500 to 1,000 training iterations until it reaches a certain accuracy, quality, right? If you train this whole thing on a quantum Boltzmann machine, and you run it on the Dynex platform, you need like 20 iterations. So you basically save 95% training iterations, and even the accuracy was higher. So what it means, I think, is going to have a huge impact on the entire industry, because imagine the likes of ChatGPT, training a gigantic amount of data out there. Imagine if they can save 95% of training.
That's a big percentage.
Yeah. So long story short, the number of chips, what you see there, is basically would be the equivalent to the number of reads on a quantum computer, right? Because the quantum computer is basically using these phenomena like superposition and entanglement to explore all the possible solutions, right? To find a set of best ones. But this is a probabilistic solution, right? So also on a quantum computer, you basically say, okay, I want to run this problem 100 times in parallel, and I want to get the best of the 100 results, right? And that's basically the same in our environment, but we call it Dynex Chips because we are basically doing it differently because we are simulating those Dynex chips. So right now, in essence, I can say, okay, I have a really complex problem to compute. I want to fold the HIV virus, for example, which you also showcased, right?
Mm-hmm.
The HIV virus, and takes 48 seconds on the D-Wave quantum computer on the hardware, 48 seconds to solve, to fold the HIV virus. And I can say now, I want to run it on the Dynex platform, but with 250 million reads, right?
Wow.
In parallel.
Wow.
And that makes in like 3 seconds it folded instead of 48 seconds.
That's
so
huge.
that means because we're having so many miners contributing right now and contributing to the proof of useful work concept here, not only do we eliminate the scaling issue of a quantum computer, we actually sometimes can even be faster because we have just of the sheer power we're putting into this. So this is really exciting.
It's mind-blowing. Thank you for that, Sumi. Question on that. So the supercomputer thing, is there like a central point for Dynex that becomes like of us become this thing, or is it spread out?
So basically, let's take the HIV virus, right? And you want to fold the HIV virus. You basically split that problem into millions of small tasks, which is called the number of reads, right? And then basically your rig is calculating it, and the rig in China is calculating it, and I don't know how many, right? You can define how many you want to use, right?
Right.
And they're all separately calculating whatever is to be calculated, but they do give themselves some sort of updates in between because they learn something in the meantime, but it's very little information. That's why we have no issue of data transfer, because typically in machine learning, you would expect huge amounts of data being transferred left and right all the time. We don't have that issue. And so they basically learn from each other, get better and better, and then they send the results back. And then basically the user or the researcher or the company who is running the computation collates that information and uses it.
Okay. That makes it a lot more sense, because I'm just curious. I see this thing as somebody who doesn't know much about like the advanced technology. I see this thing spinning on the website. It says we're making this quantum computer thing. I'm like, oh, okay. So that clears it up for sure.
Well, it's a symbol. What you have on the website. In the center, you have this organic structure, which is basically expressing neuromorphic, because neuromorphic is basically simulating the brain, kind of like a biological, organic structure. And then the metal frames around, right, means basically together, right? Together with all the GPUs and all the miners, we can solve these kind of problems. That's basically what it should showcase.
I like that. I like that a lot, actually. Okay, I have a question. So, who is the customer for Dynex? Do you guys have like a particular market you want to go after, a certain type of customer, anything like that, or is it kind of open?
So basically, every global 2000 company is at a scale where they have intractable problems. So they are our potential customers. Then we have the whole medical pharmaceutical area, right? Drug discovery, protein folding, HIV folding, cancer cures, etc., breast cancer detection, all these examples, which we have showcased. I mean, they're working already here, and we can display them. And so basically, the whole pharmaceutical world. Then you have the financial world, portfolio optimization, all these kind of things. Should I get more of Apple stock? Should I get more of this, that? What is my risk profile, and all these kind of things. You have architecture, huge space. We also demonstrated lately, a couple of weeks ago or 3 weeks ago, a task, which is, for instance, where do I place the charging stations for EVs, for electrical vehicles? What's the best positioning? Because here are points of interest. There's a lot of population here, there, etc. Right? You wanna do that, right? You can do it with our tool quite quickly. And then in general, everyone who runs, trains, maintains, or operates machine learning, and can actually even be a student who is doing his master thesis, honestly, and he wants to calculate, train a machine learning model properly and better and faster. And because he has less resources, because running a problem on a quantum computer is not cheap, Yeah. I'm not saying it's cheap on Dynex. We will see what the price will be, but it's definitely more. It's definitely faster and needs less training iterations, so it's inherently cheaper for him. He can also use it. He just fires up his Dynex, his Python, then installs the Dynex SDK, the software development kit, buys a few Dynex, because that's the currency, what you use to pay for computations. Let's say in his case, he wants to train whatever, right? He's doing some research project. Bam, gets the result directly in his Python, right? So it's not limited for large companies, small companies. I mean, this new job type, machine learning, opens it up actually for everyone. And this is why we believe this is what people start gradually realizing, the potential of basically everyone who is doing machine learning can benefit from it. And that's basically, I think, what we see right now in the latest price action.
Okay. I like hearing that. So I got a better understanding now. Another question here. So a normal user like me that I don't know how to use Python. I don't know how to use any of that. Will somebody like me ever be able to benefit from Dynex, like long term? Just like a random problem that I have.
Well, it will benefit you in a way if others solve something and make something better. For instance, let's say you're benefiting from ChatGPT today, right? Because it's better than the speech recognition. Like, I mean, that's when I say anything, but I mean, we all have our experiences with Hey Alexa or Hey Siri, which half of the time misunderstands us, right? I mean, imagine that you would have the ChatGPT-like quality on your phone every time, right? So it will have impact on your daily lives because you have all of a sudden there's a drug against whatever, right? There's better treatments for HIV, better cancer treatments, whatever, right? There's more charging stations at the best locations. The portfolios are optimized better, so it has an application impact on you, but you probably, if you don't use Python and you're not really involved in these things or machine learning, you will not really use it yourself directly, but indirectly you will.
Okay, indirectly. Hey, we got to benefit from it either way. Question I get asked all the time: what is the difference between Dynex proof of useful work and like Flux proof of useful work?
It's totally two different things.
Yeah.
So Flux is basically a platform where you can run anything on a network of GPUs, which is great, right? So if you want to render something or whatever you want to do, right, you can basically run it there. What we are doing is basically entirely different. We are basically providing quantum computing functionality to the machine learning user or to the user who needs some constraint satisfaction problem solved. That's like day and night. It's basically
like two different marketplaces, target audience kind of thing.
Completely different.
That makes sense.
Yeah. So there's no competitive situation here. I mean, we do have a partnership coming up with OCTA.
Oh, OctaSpace, really?
Yeah.
Oh.
It's in the works. Has been announced already, but it's not rolled out yet. And they do have this marketplace for GPUs, right, where you can rent out your GPU power, right? And the idea here is obviously, let's say you, right, as you're sitting there, let's say you rent out your GPU on OctaSpace, right? And let's say you have a 60% booking rate. What's happening in the 40% idle time with your GPU?
Yeah, good question. Am I mining something else? I'm hoping.
Well, doing Dynex solve meaningful calculations. So you contribute there, right? So basically here the partnership spirit is that basically unused idle time of all those platforms of Octa, of all those GPUs, is being used to do something meaningful and also make some money while doing it, obviously, right? Because it's kind of mining Dynex in the meantime. And it helps, it's a win-win situation. It helps their customers, right? So there's 100% GPU utilization. Idle time, no idle time, doesn't matter, right? It helps us because we have access to more infrastructure, even more infrastructure, which is great because I need 15% by the end of the year. Otherwise, I'm upset, right? And it's a win-win situation for everyone. And this is how I see, also potential angles with all those GPU platforms, decentralized GPU platforms, right? Especially when it comes to idle times and unused times and things like this.
Yeah, I like that a lot, man. That's something I've thought about as well. Is like, what if I don't get the job? What do I do? Yeah, so to be able to mine, been hearing that. That's a good thing for sure, man. I have a question from one of my viewers. I don't know if you know Geek of All Trades. He says, how does Dynex directly receive the results of proof of useful work after the miners process the slice of each job? So what I think he's asking here is, after the job, like what percentage does Dynex get of proof of useful work jobs?
So 95, I mean, you mean how much GPU power is used for proof of useful work on Dynex, or is it specifically to this OCTA partnership now?
No, it's just Dynex for that.
Okay, so basically, currently, everyone who studied our white paper has seen that we basically have an entangled model. So we have proof of work for securing a chain, and we have proof of useful work. Currently, 95% of the power is being used for proof of useful work, 5% for POW, right? So 95% is used for us for quantum / neuromorphic computing algorithms being run on our platform. Now, when the miner's job is finished, he submits the solution, which is basically, what is the solution? The solution are the voltages on these different Dynex chips, right? That's basically what the solution is. It's like a list of double precision values, and they are being sent to whoever is hosting, right, the jobs, right? Usually it's a file transfer for the variables. Let's say you want to solve something with 1,000 variables, you get 1,000 voltages being sent back as a result. Typically, a job duration is depends, but it's usually, I mean, except you play around and test drive the Dynex platform, Typically, a job duration is anywhere between a minute, 5 minutes, 10 minutes, maybe even longer, right? Large jobs can even last for months if you want, right?
Perfect. Question. Are we getting jobs right now? As someone who's mining, like I have a rig right here. This is mining Dynex. Are we getting jobs, or do I have to like sign up into a program to get a proof of useful work job?
No, this is actually one of the unique things that we have built here at Dynex, right? It's basically the whole job scheduling and job prioritization and job management. This sounds simple. I'm telling you, this is not a simple task because you have a very malleable environment. Miners come and go as they want. They switch on the rigs, switch off the rigs. Get tired. There's a technical issue. They have latencies, and the list goes on and on and on. So we have a job management scheduling system. So basically, when you start mining Dynex, you get automatically assigned a job. There's always a job for you because we are filling up the jobs with general problems which need to be solved, which are unsolved today, and we're combining them with customer jobs. Right. So far, we ran around like 2,000-3,000 jobs on our platform, for example, because we're yet to roll out everything publicly, and accessible, because the Dynex SDK is currently in closed alpha, and then now in a few weeks it goes to beta, and then it goes to full production according to the roadmap. But you don't have to do anything. You just run Dynex off. You compute. There comes a job. It gets replaced. This is why you have such stunningly low electricity usage. Why? Because running a Dynex chip, aka running neuromorphic chips, is basically a simulation of that chip, which means it's like a simulation can be ideally run on GPU. So an FPGA does not have an advantage over that, right? And an ASIC will never be as flexible as we need it for it. So this is like what we are
perfect
calculating
for GPUs.
here. Yeah, it's just made for GPUs. And that's why you have like really nice power draw, right? Efficiency. We can see here when we utilize the platform how efficient it is, right? We actually go head to head, with the fastest machines out there in terms of efficiency and infinite scalability almost. And price is also pretty good, so we're profitable in most cases. So everyone is happy, including the customer who can finally calculate something faster and better, right? And the miner is happy because he's not doing just hashing, but he's contributing something. It feels good, to know you're working on HIV folding, for example. It's nice that your computer does this while even making money, right? It's like perfect. So it's I think the ecosystem we're building out here is beneficial for everyone.
Yeah, because what I've seen, I don't need to get into specific coins or anything, but I keep seeing new coins that are super efficient. Then they go to FPGA, then they go to ASIC, and then we can't really use them anymore. So the fact that Dynex is benefiting from those chips, right? The really not prefers, but really kind of needs those chips. Is it safe to say it'll probably stay GPU in the future?
Yeah, 100%.
I love that.
Dynex is going to be a long-term GPU place, that's for sure.
That's great to hear. Oh, yes. I'm excited. I've always been excited, but now I'm really excited. So, yeah, no max TDP, right? Pretty safe to say that for the future, there won't be a max TDP on your cards or anything used?
Nothing.
Oh, this is great. I have 16 cents kilowatt. So, mining for me is very expensive.
Yeah, I can't imagine.
Yeah. Okay. One more question. So is there any quarterly projections? I know you said the third quarter for something, but like as far as long term, maybe getting to the point of like, this is what Dynex makes or something. I don't know if that's going to be public or that'd be more private.
I actually completely forgot to mention that. We actually also did a complete website overhaul. I know when we started off, there was no animations. It was pretty scientific website.
Yeah.
Now we try to explain it a little bit more, fresh and easier and simple. And now we actually also there is a section on the website which is the roadmap, which really break down by quarters, right? And there we show when it started, when it's completed, what is the plan. Long story short, everyone can look it up on the website under the menu item roadmap. But long story short, basically, by the end of the year, we want to have the technical infrastructure rolled out in a way that we have basically full ecosystem, right? So everyone can basically use Dynex. Everyone can download the SDK, marketplace. Everything is there, and we also start off with an initial enterprise sales team because, I mean, it's you cannot expect from large global 2000 companies to just use our tool,
Yeah.
just to compute right from the beginning. I mean, you have to have
Right.
a name, you have to build up your name, and these are key accounts. So we're gonna have like a real business. We're gonna have an enterprise sales team.
We just got to keep spreading the word of Dynex, man.
Spreading the word,
Tell your
right?
friend.
Yeah, and then towards the beginning of 2024, we're gonna like push hard on sales, right? We wanna grow the enterprise sales teams. We're gonna have more market share, 15% of the GPU miners. And actually, what's gonna be really helpful on this will be the blue chip testimonials. Like blue chip customers saying, you know what, I'm using it, and this is just great. This is gonna accelerate everything further. And then we are planning I mean, we are actually showing it today. We are showing how much of rewards was paid by customers to miners in addition to the block rewards. You can see that on Dynex Live on our website.
You said Dynex Live?
Yeah, you just go on dynexcoin.org, and then there's
Okay.
like a big green button called Dynex Live.
Okay.
And so far, I mean, obviously it's just the beginning, but we already the customers already paid 27,000 Dynex to their miners, which is also quite an amount already, just for testing. They're not even really in production and rolled out and live yet with the marketplace. And 2,736 finished jobs, right? So everyone will be able. I mean, we're gonna add some nice statistics like monthly revenues of the customers and stuff like that. But for now, we get an idea. Everyone can in real time look at it, what's happening, how many jobs finished, how many rewards were paid, and so on and so forth. All on our website now.
Okay, so y'all know where to check out Dynex. I will put a link in the description below. Anywhere else, I'll put the Discord, I'll put your Twitter, and I'll put the website for Dynex. Anywhere else they can check out Dynex?
Yeah, so basically what we have is we have dynexcoin.org/linktree, and that basically points everyone to all our social media channels.
Okay.
All the local communities, the official ones, etc. Maybe better than just pointing to Twitter. Just use the Linktree. There we have everything. And our friends in Asia and our friends in Turkey and everywhere in Persia, they can find their respective community there.
That's impressive. Well,
Yeah.
Sumi, this is not the last call with you. I'm
Yeah,
excited.
definitely not.
I love hearing the updates, man, and I see you guys just going up and up and up. And I'm not talking about the price. I don't care about the price. I mean, it's exciting, but you know what I mean? I've seen the project just move forward, and it's exciting times.
And don't forget, I mean, we are barely 9 months old.
Yeah. You've accomplished a lot. 9 months.
Yeah.
So the future's bright. Any last words, Sumi?
No, just spread the work, keep contributing. Thank you so much. And yeah, I appreciate you giving me the time and the space here to elaborate a little bit on our latest progress. Thank you so much.
Anytime, Sumi. Thank you so much.
Alrighty.